Alright, welcome back to part 2 of this video. So again, we're just going to be getting some more practice finding all these different pieces of the parabolas. So let's start with example 3. So for example 3, we have x minus 4 all squared minus 1. We want the vertex, the axis of symmetry, and if it opens up or down. So luckily this one is already in vertex form, so it makes it nice and easy. So remember, for the x, we do flip the sign of whatever's there, so it's x minus 4, so it's going to be a positive 4, comma, the number on the outside, so negative 1. Axis of symmetry is going to be x equals 4, because that was our x value. And then since it is positive on the outside of the parentheses, it is going to open up. For number 4, it's going to be the same exact thing. So vertex, we use the opposite number of the number inside, or sorry, opposite sign of the number inside. So that's going to be positive 7, comma 3. Axis of symmetry will be x equals 7, because that was our x value. And in this case, because we have a negative right there, it is going to open down. All right. So example 5, this one is not in vertex form, unfortunately. But don't forget, we do have that little formula that lets us find the vertex. So it all starts out by doing negative b over 2a. So in this case, our a is negative 1, b is negative 4, c is 5. So if we plug those in, we get negative 4, or just positive 4, over 2 times negative 1, which is 4 over negative 2, or negative 2. So we know that the x value is going to be negative 2. We just need to find the y value now. To find the y value, we're going to plug it back in to the original function. So that's going to be negative 2 squared minus 4 times negative 2 plus 5. So this is going to be negative 4 plus 8 plus 5. And if we add all of those together, we should get 9. So there you go, negative 2, 9 is our vertex. For the axis of symmetry, same thing as before, x equals negative 2. And since a was negative, it was going to open down. All right, let's look at example 6 now. So same exact idea. We start off with negative b over 2a. This time our a is 1, b is 4, c is negative 5. So negative b over 2a is going to be negative 4 over 2 times 1, which is negative 4 over 2, which is negative 2. It's going to be negative 2 comma something. Let's plug it back in and see what we get. It's going to be negative 2 squared plus 4 times negative 2 minus 5, which is going to be 4 minus 8 minus 5, which is negative 9 in this case. So we got negative 2, negative 9 as our vertex. Axis of symmetry is still x equals negative 2. And it is going to open up. Okay, let's find some x-intercepts and y-intercepts now. So remember, for x-intercept, we are setting y equal to 0. So y equals 0. Which just means we're going to set f of x equal to 0, or just that whole expression equal to 0. So we got 2x squared minus 9x plus 7 equals 0. Again, we can go ahead and factor this time. So we have a, c, and b. A times c is 14, b is negative 9. So we're looking for two numbers that multiply to positive 14 and add to negative 9. So those would be negative 2 and negative 7. So I'm going to go ahead and split b with that. So 2x squared minus 2x minus 7x plus 7 equals 0, and then we can group it. So from this first group, we can take out 2x. So we got 2x times x minus 1. And from the second group, we can take out a negative 7. It's going to be minus 7 times x minus 1. And if we see the insides of the parentheses match, that's how you know we're doing it right. That x minus 1 times 2x minus 7 equals 0. And if we set both of those equal to 0, that's going to give us our two x-intercepts. In this case, x equals 1 and x equals 7 halves. So to put them as intercepts, it would just be 1, 0 and 7 halves 0. Y-intercept next. So y-intercept, we're going to set x equal to 0. And this is always the easier one. So if we plug in 0 for x, you're going to notice that most everything cancels except for that last number. So our y-intercept is just 0, 7. And you may have picked up on this already, but if it is in standard form, then your c is going to be your y-intercept. That's it. So we can just take that last number. That's your y-intercept. All right, so moving on to example 8. So again, let's start with the x-intercept. So we got x squared minus 7x plus 12 equals 0. Yet again, we can factor this. So our a times c is 12 and our b is negative 7. So we're looking for two numbers that multiply to 12 and add to negative 7. So in this case, that is negative 3 and negative 4. And the really good thing is that in this case, because a is 1, we don't have to go through the trouble of splitting it. We just know that those are going to be what we end up factoring it into. So x minus 3, x minus 4 equals 0. And set them both equal to 0. So we get x equals 3, x equals 4. So 3, 0, and 4, 0. All right, next up, we need to do the y-intercept. And again, you can absolutely just use that trick of it's going to be c because everything else is going to cancel out. But just to show it, if we plug in 0, that's just 0, that's just 0, so we are left with just 12. All right, example 9. So this one's going to be a little bit harder. specifically for the x-intercept. So we have x squared plus 3x minus 7 equals 0. Only this time we can't factor it. There's nothing that multiplies to -7 and adds to 3. So since we can't factor this one, we're going to have to use quadratic formula. So as a reminder, x equals -b plus or minus the square root of b squared minus 4ac all over 2a is the quadratic formula. If we go ahead and plug everything in, we have -3 plus or minus the square root of 3 squared minus 4 times 1 times -7 all over 2 times 1. All right, if we start simplifying it a bit, I mean -3 plus or minus 3 squared is 9. -4 times 1 times -7 would be plus 28. And 2 times 1 is 2. Then we can go ahead and simplify that square root a little more. So it's going to be -3 plus or minus the square root of 37 all over 2. And the square root of 37 does not simplify in any way. So we're going to just leave it like that. We're going to have it as an exact answer in this case. If you need to, you can always plug this into your calculator to get your approximate answers. But for our x-intercept, we are going to want to write both x-intercepts. So don't forget, we are going to split that plus and minus. So that means our first x-intercept is -3 plus square root of 37 all over 2 comma 0. And our second intercept is -3 minus the square root of 37 all over 2 comma 0. All right, since that was busy enough, I'm going to assume that all of you are okay with using that trick and saying that our y-intercept is just going to be 0, -7. Again, that just comes from grabbing that last number. Okay, so with that said, let's go ahead and move on to a couple of word problems. All right, I know nobody likes word problems, but luckily these are not too bad. You've already done everything you need to do to be able to do these. It's just going to be using the vertex. All right, so if a manufacturer of lighting fixtures has a daily production cost of that, where C of x is the total cost in dollars and x is the number of units produced, then for part A, how many fixtures x should be produced each day to minimize the cost? In part B, what would it cost C of x to produce that many fixtures? Okay, so here's the thing. I know there's a lot of words and everything, but in the end, we have a quadratic function right here. We know that it opens up, and we know that it's going to have a minimum. So if we're talking about that minimum, well, that's just the vertex. So we're just using the vertex again. So this is going to be -b over 2a. So that's going to be -10 or +10 over 2 times 0.25, which is 10 over 0.5, which should be 20. That's the answer to part 1. If we want to know what would it cost, that's essentially just asking for the y-coordinate of the vertex. That's asking what the actual value is there. So all we're going to do is take that 20 and plug it back in. So we're going to have 0.25 times 20 squared minus 10 times 20 plus 800. If we go ahead and start simplifying this is going to be 0.25 times 400 minus 200 plus 800. 0.25 times 400 would be 100. If we add all of these up, we get 700. All right, let's go ahead and move on to the next one. A ball is thrown upward with an initial velocity of 48 feet per second. If the ball started its flight at a height of 8 feet, then its height, h of t, measured in feet above ground level at time t, can be determined by that function. So A, what is the maximum height of the ball? And B, when does it reach its maximum height? Again, it's talking about maximum. In this case, we have a negative right here, which means our parabola would be opening down. So the maximum point, again, is that vertex. So we're just finding the vertex. So let's start off with negative b over 2a. So it's going to be negative 48 over 2 times negative 16, which is going to be negative 48 over negative 32. And that's going to be 1.5. All right, now be careful, because remember, this is our variable. It's like our x in our vertex. So 1.5 comma something is going to be our vertex. But in this case, we're not calling it x. T is our variable, right? T is time, which is actually part B. Part B is asking for the when. Right, so be careful. The 1.5 seconds, that is for part B. That's when it reaches its maximum height. To find the maximum height, that's where we're going to go ahead and plug it back in. So we got negative 16 times 1.5 squared plus 48 times 1.5 plus 8. And then at this point, I don't necessarily recommend you trying to just do this in your head or anything like that. Just plug this whole thing into your calculator. Your calculator will go ahead and spit out 44. So 44 feet was the maximum height. All right, last one, same idea. Some fireworks are fired vertically into the air from the ground at an initial velocity of 80 feet per second. The height of the fireworks is given by the function h of t equals negative 16t squared plus 80t, where t is the time in seconds. Find the maximum height of the fireworks just as it explodes, and how long does it take to reach its maximum height? All right, so again, we're talking about maximum, we're talking about vertex. So start out with negative b over 2a. It's going to be negative 80 over 2 times negative 16, which is negative 80 over negative 32, which is 2.5. So 2.5 seconds. That's going to be the how long it takes. To find the maximum height, again, we're just going to plug it in. So negative 16 times 2.5 squared plus 80 times 2.5. You can plug that into your calculator. It should give you 100. So 100 feet is how high the firework is whenever it explodes. All right, hopefully this made sense. Hopefully it gave you a little extra practice. Again, the main thing to remember is if it's in vertex form, vertex is really easy, just grab it off. But if it's in standard form, just don't forget this formula. All right, with all that said, I will see you in the next notes. Thank you.